Have you ever wondered how glass is made? In this fun and easy science video for kids,
Welcome to this explainer. Today, we're going to look at the world through a totally different lens. Literally. I'm going to show you how a plain, simple pile of sand transforms into some of the most amazing, high-tech stuff on planet Earth. And to make this really fun, we're going to explore this exactly like a hyper-curious elementary school kid would explain it at the world's coolest science fair. So get ready for some wild analogies and to uncover the hidden magic in the everyday things around us.
So right off the bat, I want you to think about something. Have you ever actually stopped to wonder how the exact same stuff holding your morning apple juice is also carrying the internet straight into your house? I mean, from the screen you're staring at right now to the giant windows on skyscrapers, glass is absolutely everywhere. But how does it do so many completely different jobs? Why is it so perfectly special for both holding a simple drink and transmitting billions of CAD videos at the speed of light?
Well, let's jump right into section 1, the ultimate extreme recipe.
Okay, so you can kind of think of the glass-making process like the most extreme, high-stakes baking recipe ever created in human history. Our main ingredient? It's actually just sand, specifically silica sand, and that makes up about 72% of the whole mix. We take that sand, mix in a dash of soda ash and some limestone, and then, just like tossing leftover chocolate chips into a fresh batch of cookie dough, glass makers add in recycled glass, which they call cullet. Actually, mixing this cullet in is a super smart trick because it saves a massive amount of energy.
All right, moving on to section 2, inside the giant oven. Now here's the catch with our extreme recipe. You can't just stir this up in a plastic bowl and pop it in the microwave. No way. We are talking about a mind-blowing temperature of 1700 degrees Celsius. To put that crazy number into perspective, your family might cook a frozen pizza at, maybe 200 degrees? This oven is hot enough to literally melt some types of solid steel. It completely turns solid rocks into a glowing, bubbling syrup.
Inside that massive industrial furnace, you have these giant gas or oil flames blasting heat directly over the raw materials. The heat transfers into the melting batch primarily through intense radiation. Just imagine standing near a massive, roaring bonfire, but multiply that heat by 1,000. The heat radiating from those flames just completely breaks down the sand and rocks right into a liquid state.
But, the melting is really just the beginning of the magic. That extreme heat actually creates these swirling convection currents inside the tank. It's almost exactly like watching a rolling, boiling pot of water on the stove. These natural currents act like a giant invisible spoon, perfectly mixing our glowing syrup until it's totally smooth, homogeneous, and totally free of any tiny bubbles.
Up next is section 3, shaping the glowing syrup.
Okay, so once we have our perfect molten syrup, we have to hurry. Glass likes to cool down fast, and if we aren't quick, it's just going to freeze right back into a useless solid rock. If a factory wants to make totally flat windows for a house, they do something absolutely incredible. They pour the liquid glass onto a 300-meter-long river of actual fluid metal, specifically a molten tin bath. Because the liquid glass is lighter, it just floats perfectly flat on top of the liquid metal, creating this continuous, flawless ribbon before it's finally drawn out and cut to size.
But what about everyday things? Like your favorite juice bottle. Well, for containers, the hot syrup is chopped into flaming, glowing chunks called gobs. These gobs are dropped straight into metal molds and then actually blown into shape with compressed air. It is exactly like blowing up a balloon, but instead of flimsy rubber, you are literally inflating liquid fire.
Let's transition to section 4, cooling it down.
You might not realize this, but cooling the glass down is honestly just as important as heating it up. If you cool it wrong, it's going to shatter into a million pieces. So, to make standard glass, we cool it super slowly in a long, temperature-controlled tunnel called a layer. This slow process is called annealing, and it basically relaxes all the pent-up internal stress inside the glass. But if we want to give the glass superpowers and make it incredibly strong, we use a rapid cooling trick called tempering, or the quench.
So here is how the quench works. The hot glass gets blasted simultaneously on both sides with high-pressure cool air. The outside of the glass freezes instantly, right? it becomes totally rigid. But the inner core is still super hot. As that inner core eventually cools down, it tries to shrink. But since the outside is already frozen solid, the shrinking core aggressively pulls against the rigid skin. This dynamic creates a permanent, invisible shield of compressive stress on the outside. It literally turns regular glass into super strong safety glass.
All right, let's look at Section 5, Everyday Glass Wonders.
It's fascinating because how we treat the glass on a microscopic level completely changes its superpowers for the things we use every single day. We can even chemically alter it to do things that seem downright impossible. Take your smartphone screen, for example, which takes a massive beating. Scientists use a chemical trick called ion exchange. Imagine a triangular billiards rack packed tightly with 15 pool balls. There's plenty of room for them to roll around in there. Now swap those pool balls out for slightly larger tennis balls. The rack is suddenly packed way too tightly. By chemically stuffing larger ions into the glass surface, it creates this intense armor that strongly resists scratches and drops.
Which brings us to Section 6, High-Tech Glass Superpowers.
You see, glass isn't just for looking through or tapping your fingers on. It's actually the invisible, high-speed backbone of our entire digital world. To make fiber optic cables for the internet, we don't just use regular sand. We use ultra-pure silica, shaped into large rods called preforms. And to melt these guys, they are placed in a vertical furnace and heated to a staggering 2,000 degrees Celsius. That is even hotter than our giant glass melting oven we talked about earlier.
Then, from that melting preform, a continuous strand of glass is pulled straight down. It gets drawn out at thousands of meters per minute, constantly monitored by precision lasers until it is exactly 125 microns thick. That is literally the exact thickness of a single human hair. After getting a protective plastic coating, these tiny, flexible glass hairs are exactly what carry massive amounts of internet data across entire oceans, using just rapid, blinking pulses of light.
It is totally wild to think about, isn't it? From a simple pile of hot sand baking in a giant oven, to the invisible, glowing threads connecting the entire globe. So I want you to look around your room right now. Seriously, look around. How many hidden glass superpowers can you spot shaping your own life? Whether it's the bulb lighting your desk, the screen you're watching right now, or the invisible cables delivering this very explainer to your device, glass truly is a modern marvel. Keep looking for the magic in everyday things.
If you enjoyed this video, please like, share, subscribe, and hit the bell so you never miss a new lesson.